Hello dear students, welcome to Just Concepts. In this video, I'll be giving you some basics of resolving a vector along x and y axis and doing addition or resultant of one or more than two vectors which are first to be resolved and then we have to add them, right? So this is a requirement throughout your grade 11 and grade 12 because there will be a lot of scenarios when more than one vector or like a force or a velocity, for example, would be acting on an object, right, simultaneously, and you would be required to find the resultant. Now the only way you can efficiently manage this is while resolving these vectors along x-axis and y-axis. So once you resolve along x and y, the components along x can be added or subtracted together and y-axis can be added or manipulated together. It becomes very easy to manipulate the vectors, right, using the technique of resolving a vector, or you can call it a technique of componentization. Okay, so we will start with an example where there are two forces of 10 Newton and 20 Newton. These forces are acting simultaneously on any object at point O, right? So at this time we are not worried about from where these forces are coming in and whatnot. We are primarily focused on how do I find the resultant of these two forces which are acting on the same point, on same object. Understand, using the angle formula, right, a square resultant of a vector a square plus b squared plus 2ab cos theta, that formula is just like give you a magnitude, right, and that is not always efficient because if you have one more force here, then that formula will not work because that's only for two vectors. So we'll start with very basic. So we have two vectors I cap. This is a unit vector along positive x-axis, right? Then we have a vector j cap. Vector j cap, this is a unit vector along positive y-axis. Okay, so remember one thing, when you are resolving a vector, first you have to find the components. So for components, let's focus on this 10 Newton force, right? So this 10 Newton force can be resolved in two components, one along the x-axis and one along the y-axis. So this will become like this. So one component will go like this and one component will go like this, right? So this is how we have to visualize this, because in this resolution of vector, your visual intuition is the most important thing in judging the angles, etc. And the other concept is, along the axis from which you are measuring the angle, the component will be vector cos, that means 10 cos 45. So in this case, 10 cos 45 degrees, this will be our x component of vector, right? So again I am repeating, from the axis from where you have given the angle, so that will be 10 cos 45, and so this will be like 10 cos 45 here. Now along the y-axis, this will be 10 sin 45. So the other one becomes sin and this one becomes cos, right? Okay, so this will be what? So this vector, let's say we call this force F1. This force F1 now can be written, in the component form like this. This is the x component, this is 10 cos 45. Obviously this is just a number, 10 is a number, cos 45 is a number. To give it direction, we have to multiply this with I cap, because this is pointing towards positive x direction, this will be I cap, plus another component that would be along positive y direction. Yes, you have guessed it right, this will be 10 sine 45 and then j cap. So if I plug in the values, this will be 10 by root 2 I cap plus 10 by root 2 j cap. This becomes my F1. Right. Similarly, when we have to resolve this 20 Newton, let's call this F2. So F2 will be resolved like this. This is your F2 vector, right? So it will have two components, one along positive x-axis and one along negative y-axis, like this. So this is where I said your visual feel of the vector has to be very, very strong. This vector will be a resultant of two vectors. One is positive x and one is negative y. Why it is not positive y? Because you can feel it. Why would this go in positive y direction? This is a vector which is inclined like this. So when you resolve this, this has to be one here and one here. Then only the resultant can come down like this. Right? So this will naturally come with some practice. So when you do when you encounter such scenarios in your problems, slowly and gradually you will become comfortable. Right? So that's how we have to understand this. So now F2 can be written as, so there will be a 20 cos along x-axis, 20 cos 30, because the angle has been given from x-axis. So it is 20 cos 30 I cap, 20 cos 30 degrees times I cap plus. Now understand, this is one component, other component would be like this, and this is along minus j axis, right? This is a negative, this is plus j cap, this is minus j cap. So this has to be written as minus 20 sine, because the angle has been given from x axis, so y axis would be sine 30. So this is 20 sine 30 times j cap. This is how you have resolved this. You can plug in the value. So this will come as cos 30 is root 3 by 2. So this will be 10 root 3 I cap minus sine 30 is 1 by 2. So 1 by 2, 20 will be 10. So minus 10 of j cap. Right. So this is your F2 vector. Let's put a vector sign because these are vectors. So once you have figured these two vectors in IJ form, so what is the advantage? The advantage now, dear, is when you have to add these vectors, you can simply add the I components together and j components together and put IJ at the correct places. So the resultant of these two forces R can be written as F1 plus F2, which is 10 root 2 plus 10 by root 2 plus 10 root 3. These are the I components. So you will do I cap. Now here this is plus, this is minus. So this will become 10 root 2 minus 10. Right? This will be 10 root 2 minus 10 times j cap. So this becomes your resultant. As simple as that, right? Now you can just, I'm not doing the calculation part because that is not the idea here in the video. It is just to give you the procedure and some conceptual journey of resolving a vector. Understand, if someone asks you what is the magnitude of this resultant, you have to just do the square of this component plus square of this number and then add and do square root. That is something you should already know, because for a vector written in this form, let's say a vector is written in this form, x I cap plus y j cap, your magnitude of A is always square root of x square plus y square. So here it will be, this number is your x number, this number is your y number. You will just do x square plus y square and then square. You can also find the direction by just doing tan theta from the positive direction of x-axis, the angle would be tan theta is equal to y by x, this upon this. Okay, in another example, we will also get a real feel of finding the direction also. In this example, I was more trying to give you a basic journey of how to resolve, right? A basic journey of how to resolve. Obviously, you could have also solved this question by using the a square plus b square plus 2ab cos theta formula. Because as a student, sometimes you get curious why we are doing all this when there is a direct formula. Yes, you can use a direct formula, no one can stop you, and rather it is easy also, but understand that formula is only good for two vectors. If there is one more vector, then this a square plus b square 2ab cos theta would be very inefficient, because first you will find resultant of two vectors, and with resultant of those two vectors you will find the resultant with the third vector, right? So all those things will come into picture, and you have to also find out the angle of that resultant with the third vector. This is going to be very tedious task. So whenever we are put up a situation like this, your first choice should be to resolve the vectors in IJ form and add or subtract accordingly as per your need. As you saw in this problem, right, we have simply resolved. You can watch this video again and again if you want, but this is a very fundamental point of your journey of vectors. I am not giving you any fancy example. This is a very straightforward example. Please practice this. So let's move on to the next example. Now an object is having three velocities like this, one like this, one like this, and one like this. Now purposefully I have not drawn the XY guideline here, because many a times in the problem you will not be given the x-axis and y-axis. So you will have to assume a suitable x-axis and suitable y-axis, right? In many cases your x-axis would simply be horizontal and your y-axis would be simply be vertical. But when you do fourth chapter, especially questions regarding the object moving on an inclined plane, you will see that x-axis is better taken along the incline, because that's where the object motion is happening, right? So at least one of the axes should be aligned with the object's motion direction. That makes things easier, right? So in this case, rather it's easy. We will simply take the x-axis and y-axis as horizontal and vertical axis. So first let's just draw x-axis and y-axis like this. This is your x-axis and y-axis, right? So now let's try to write these vectors in terms of ijk. So let's first start with v1. So now you can see here the angle of v1 with x-axis is 0, because v1 is totally along x-axis. So there cannot be any component of v1 along y-axis, because it is totally aligned in x direction. So this can simply be written as 10 I cap, because it is along positive x-axis, right? In many cases one of the force or velocity will be along either along x-axis or y-axis. So uske liye to very easy, we can simply just use like this 10 I cap, right? Now coming to v3. V3 is also easy, that's why I am writing it first. v3 is along negative y and totally along this. There is no component along x-axis, so this can be written as minus 15 j cap. Why minus? Because it is along negative z-axis, sorry, negative y-axis, so negative j, right? Now coming to v2. Understand, for v2 first we have to judge the angle. See, there are two ways you can go about it. Either you can take the angle as 120 and you can write like this: v2 is 5, since the angle is being formed from x-axis, that means the x component would be cos 120 and the y component would be sin 120. So you can simply write like this: 5 cos 120 I cap plus 5 sin 120 degrees j cap. So here there is a minor but important concept. When we take the angle of the vector from the positive direction of x-axis measured anti-clockwise, right? Angle is measured from positive x-axis and in anti-clockwise direction, then you don't really bother about whether it is a plus I or minus I or plus j or minus j. Your sine or cos will automatically tell you whether it is coming towards plus or minus. Let's say in this case, if we put the values of cos 120, my dear friend, is minus 1 by 2. So this is minus 5 by 2 I cap. Cos 120 is minus 1 by 2. If you do not know value of cos 120 or whatever trigonometric ratio of higher angles, then you can watch my video on basic trigonometry needed for grade 11. For now, you can just understand or take it as a fact that cos 120 is minus 1 by 2. Now, sine 120, my dear friend, sine 120 is plus root 3 by 2. So this will be plus का 5 root 3 by 2 j cap. So you see, automatically I have got a negative sign along I cap. That means my resolved vector would be along minus of or negative side of x-axis, and you can get a visual feel also. As I said, the visual feel is rather more important. So if you see the vector like this, if you resolve this v1 or sorry v2, so v2 will have one component v2 sine 120 like this and v2 cos 120 like this, because the vector is oriented like this. If a vector is oriented like this, its component has to be like this, right? So one component has to come along negative x-axis and the y should be positive, and that's how they are coming. Now this is your personal choice. You can go with the, you don't want to bother yourself what is positive, what is negative, so you just plug in the value of angle, but remember then you measure the angle from the positive direction of x-axis in anti-clockwise direction, right? But I would rather, and again this is depend on person to person, I would rather give you a visual feel. So always try to find the smaller of the angle. So in this case you can write it like this angle is 60 degrees, because this complete is 180, so this is 60. So if I were to resolve this, I would rather say this is v2 cos 60 and v2 sin 60, v2 cos along x-axis because the angle is being formed from x. Now since I have manipulated, this angle is not measured from anti-clock positive direction of x-axis, so I'll have to go with my visual feel, right? That means it is coming along this. So this is v2 cos 60 but with a minus sign. So if you write it like this, this will be 5 cos 60. I have to put a minus sign from my side because I have taken this angle which is not from the positive x-axis. In that case, I am using my visual feel and going ahead with minus sign. Somehow I find myself more comfortable with this approach rather than, or I mean you can be equally comfortable, to be honest, but when we do the fourth chapter, guys, so this x and y axis will not be truly always demarcated that this is positive, this is negative and all that, right? So whichever angle you feel this is smaller, and you draw the forces, resolve the forces quickly, not getting into the hassle of positive direction of x-axis, the anti-clockwise measurement and all that. This is easy, and you will see this when you do the questions of force, especially the inclined plane problems, and you see this method is more efficient, taking the smaller of the angle and judging the direction. Because one more thing, you are doing this I cap and j cap to a certain extent. After a certain extent, you will just be adding these component or subtracting this component as per the direction orientation, right? So this I cap and j cap are going to be immaterial once you become more comfortable using resolved form of a vector. So anyways, and coming back to this, 5 cos 60 I cap minus के साथ, now 5 sin 60 j cap, the answer remains same. 5 by cos 60 is 1 by 2 plus का, so this is I cap. Sin 60 is plus root 3 by 2, so this is 5 root 3 by 2 j cap. So now I have written V1, V2 and V3. Adding these is no big deal. Adding the resultant vector VR is, what do we have for I cap? 10. There is no I cap here, and this is 10 minus 5 by 2. So this is 10 minus 5 by 2 I cap. What do we have for J cap? There is no J cap here. Here minus 15 and here 5 root 3 by 2. So this will be plus ka minus 15 plus 5 root 3 by 2 J cap. Again, these values you can calculate here. This is not my agenda to match this answer with some textbook answer. This was just to give you a real feel. Understand one thing, ultimately after adding this I cap and J cap, coefficient can come either positive or negative depending on these values. So your vector would be oriented according to the directions of I cap and J cap only. Okay? So this was the second example where we resolved three velocities like this. Okay? So now we'll take one more example here. We'll take one more example here. I've taken this example from H.C. Verma book, right? Find the resultant of three vectors shown. So there are three vectors. Maybe these are displacement vectors. Object might be under motion, right? And then the object is moving like this. So there are three displacement. First 5 meter at an angle 37 degrees from the x-axis, then 3 meters, then 2 meters like this. And now we are supposed to find the resultant of these three vectors. So let's give them some name. Let's call this point O, this point A, B and C. So first we will write OA vector. Now I'm going a little fast because by now you might have got some idea or some hang on the resolution of vectors. So let's just go a little quickly. OA. So OA magnitude is 5. So it will have a 5 cos 37 here and 5 sin 37 here. So this will be 5 cos 37 degrees I cap plus 5 sin 37 degrees J cap. You can clearly see it will be plus I cap and this is plus J cap. So this is like this. I have resolved like this. Okay. Now 37 is a very special angle, right? It comes from a triangle. I can show you here. 37 comes from a triangle whose sides are basically 5, 3 and 4. Okay. So obviously this angle is 90 degree. So one of this angle is 37. Which angle is 37? Which is smaller. Smaller angle is come from smaller side. So this angle will be 37 and this angle from the angle sum would be 53. So please remember this triangle orientation, 37 53 combination and sides would be 3 4 5. So यहाँ से अगर आप वैल्यू देखेंगे cos 37 की, cos 37 would be nothing but basically 3 by 5 and sin 37 would be sorry this is, I have made a mistake, I guess. This is 53. Okay, there 37 3 there. So cos 37 is 4 by 5 dear. 4 by 5 adjacent side upon hypotenuse. 4 by 5 sin 37 is 3 by 5. Right? Cos 37 is 4 by 5, sin 37 is 3 by 5, or I can say cos 53 is 3 by 5 and sin 53 is 4 by 5. Right, so you can remember these values. Rather than remembering these values, you will remember these eventually, but if you remember this triangle orientation, you will always get to these values quickly. So this will become cos 37 is 4 by 5, 4 by 5, this will become 4 I cap plus this will be 3 J cap. This is your OA vector. So we have resolved first vector I and J. Look at the AB vector, guys. AB vector is purely along x-axis, so there has to be only one component I cap and completely 3. So AB vector can be written as 3 I cap, because it's totally along x-axis, so it cannot have any component along. You can also feel it like this. The angle is 0 here, so it will be 3 cos 0. Cos 0 is 1, 3 I cap, and 3 sin 0, sin 0 is 0, that means 0 j cap. So that way also you can visualize. So AB is this. Let's talk about BC vector, my dear friends. BC vector is purely along y-axis, so this will be 2 j cap because it is along positive. So resultant R would be nothing but OA plus AB plus BC. OA is 4I, 3I, this will be 7I. Sorry, this will be 7I cap, and 3j plus 2j, that means 5j cap. This is your resolved vector. Magnitude of R would be square root of 7 square, which is 49 plus 25. This is the magnitude. You can do the calculation. And the angle of resultant, right? So let's draw a resultant here. Resultant is this. So basically resultant is going to be like this vector, because it's, let's say it is displacement. So original to final, right? And you are interested in this angle now, right? Let's say if this is tan theta, this tan theta is always equal to, we are measuring theta from x-axis, so it will be y component upon x component. So this will be 5 by 7. So theta will be tan inverse 5 by 7. Right? So this is one more example to make you comfortable with the resolution of vectors. Right? See, there are 3 vectors. If you want to resolve them one with the formula, it will be too much problematic, while this is so easy. Once you understand and get a hang of it, again I'm saying it is going to be very, very easy, guys. It's very easy, but sometimes I have seen students do struggle even till 12th grade resolving vectors, and chapters like electrostatics and all that, where not many force equations come, they are not able to handle those questions efficiently. So don't be in that uncomfortable zone. Make yourself comfortable. Okay. Now I am giving you homework problem. This is also from H.C. Verma. 3 vectors like this, 2 meter 30 degrees. This is DE and this is BC. We want to find out resultant vector of OA vector plus DE vector plus BC vector. Okay, try to do it and try to get to the correct answer. You have to resolve these. OA will be resolved cos and sine. DE is just purely along negative z-axis, so it will be anyways minus 1.0 j cap, just minus j cap, and BC would be BC cos and BC sine. Cos and sine. Cos is coming along negative x-axis, it will be minus I cap, and this will be plus. Hope this helps you. Thank you very much.